Have you ever wondered what happens when too much current flows in an electrical circuit? That's where a circuit breaker comes into action. In today's video, we will learn the working principle, types, and importance of the circuit breakers in electrical power system. A circuit breaker is a switching device that can be operated manually or automatically for controlling and protecting an electrical power system. It consists of two main contacts, a fixed contact and a moving contact. The contacts are normally closed and allow current to flow through the circuit. When a fault occurs, such as short circuit or an overload, the contacts are separated by a mechanism that releases stored potential energy. This mechanism can be spring operated, pneumatic, hydraulic, or magnetic. Separating the contacts forms an arc, which is a highly ionized conductive plasma. This arc must be extinguished quickly to prevent damage to the contacts and surrounding equipments. Therefore, circuit breakers use various methods to quench the arc, such as cooling, compressing, or replacing the ionized medium with fresh gas. The choice of arc quenching medium depends on the voltage level and current rating of the circuit breaker. Circuit breakers protect electrical circuits from damage caused by overcurrent, short circuit, or overload. They interrupt the flow of current when a fault occurs and restores it when the fault is cleared. Unlike a fuse, which needs to be replaced after one operation, a circuit breaker can be reset and reused multiple times. Circuit breaker is mainly classified into two types: low voltage circuit breaker and high voltage circuit breaker. Low voltage circuit breaker is further divided into miniature circuit breaker, which is called a MCB, molded case circuit breaker, that is MCCB, earth leakage circuit breaker, that is ELCB, and residual current circuit breaker, that means RCCB. MCB is an automatic switch that opens when excessive current flows through the circuit. It can be reclosed without any manual replacement, unlike the fuse, which must be replaced or rewired once it breaks. This is the main reason why MCBs are used as an alternative to the fuse in most of the circuits. Handling MCB is relatively safe and it quickly restores the supply. It can be reset quickly and does not demand more maintenance. MCBs have ratings under 100 amperes. There are 6 types of the MCBs, and they are A type, B type, C type, D type, K type, and Z type. A type MCB trips off the circuit when the current exceeds 2 to 3 times the actual current. It is highly sensitive to the short circuit, and hence we can find its application in the manufacturing of semiconductors. B-type MCB trips off the circuit when the current exceeds 3 to 5 times the current flow and find its application in cable protection. C-type MCB trips off the circuit when the current exceeds 5 to 10 times the actual current flow and find its application in domestic as well as commercial applications like transformers, lighting circuit, and IT equipments like personal computers, servers, and printers. D-type MCB trips off the circuit when the current exceeds 10 to 20 times the current flow. It finds its application in motors. K-type MCB can withstand up to 8 to 12 times the current flow and find its application in heavy-duty loads like compressors, winding motors, and X-ray machines. A MCCB is an electrical safety device used to protect circuits from overloads and short circuits, typically handling higher currents than MCBs. A frame made up of high-strength insulating material houses all internal components in the MCCB. Many models of the MCCB offers adjustable trip settings. which allows customization of protection for specific electrical loads. They operate at higher capacities than MCBs, commonly ranging from 15 to 2500 amperes. MCCBs can be used for manual switching, which facilitates power control during maintenance and emergencies. MCCBs are widely used in industries for motor protection, welding machines, and heavy-duty feeders. It is also used for commercial purpose for power distribution in restaurants, schools, and offices. RCCB is basically an electrical wiring device that disconnects the circuit whenever there is a leakage of current flow. It is the safest device to detect and trip against electrical leakage current, thus ensure protection against electrical shock caused by direct contacts. RCCB is generally used in series with the MCB, which protects them from overcurrent and short circuit current. It ensures 100% detection of leakage current and is available to sense the AC as well as DC leakage current. ELCB have the same function as RCCB but are voltage sensing device. However, this is an old technology and is not in common use. ELCB is working based on earth leakage current. These devices measure the voltage on the earth conductor, and if this voltage was not zero, this indicates a current leakage to earth. High voltage circuit breakers is further divided into oil circuit breaker, air circuit breaker, vacuum circuit breaker, and SF6 circuit breaker. An oil circuit breaker is a type of circuit breaker that uses insulating oil as a dielectric medium to extinguish the arc formed during the fault conditions. When a fault occurs in the electrical system, the contacts open under the oil and an electric arc is formed between them. The heat generated by the arc causes the surrounding oil to vaporize, which helps in extinguishing the arc. Oil circuit breaker may be of two types: bulk oil circuit breaker and minimum oil circuit breaker. Air circuit breaker are of two types: air brake circuit breaker and air blast circuit breaker. In air brake circuit breaker, air at atmospheric pressure is used as an arc quenching medium. In this type of circuit breaker, principle of high resistance is employed for arc interruption. In air blast circuit breakers, compressed air at a pressure of 20 to 30 kg per centimeter square is used as an arc quenching medium. Air blast circuit breakers are either cross blast or axial blast circuit breakers. In cross blast circuit breaker, a high pressure blast of air is directed perpendicular to the arc for its interruption. While in axial blast circuit breakers, a high pressure blast of air is directed longitudinally or in line with the arc. Vacuum circuit breaker use vacuum as arc quenching medium. It is very simple in construction as compared to any other circuit breaker. Their construction is mainly divided into three parts: fixed contact, moving contact, and arc shield, which is placed inside the arc interrupting chamber. The fixed and moving contacts of the breaker are placed inside the arc shield. An arc shield is a component that prevents metal vapor coming out from the arc on the outer insulating envelope. Therefore, it is also called as vapor condensation shield. The outer insulating envelope of vacuum circuit breaker is made up of glass because the glass envelope helps in the examination of the breaker from the outside after the operation. If the glass becomes milky from its original finish, then it indicates that the breaker is losing vacuum. The metallic bellows made up of stainless steel is used to move the moving contacts. The design of the metallic bellows is very important because the life of the vacuum circuit breaker depends on the ability of the component to perform repeated operations satisfactorily. SF6 circuit breaker use SF6 gas as arc quenching medium. SF6 circuit breaker is further divided into two types: puffer type SF6 circuit breaker and non-puffer type SF6 circuit breaker. In puffer type SF6 circuit breaker, fixed contact and moving contact are closed at the time of normal operating condition. When fault occurs, moving contact will move backward along with the moving cylinder. As moving cylinder moved, SF6 gas present between moving cylinder and fixed member will get compressed. Arc is formed between fixed contact and moving contact. Compressed SF6 gas is allowed to pass on to the arc through the nozzle, and due to high dielectric strength of SF6 gas, arc interrupted. When there is a fault in the non-puffer type SF6 circuit breaker, the moving contact begins to separate from the fixed contact. The valve connected with the SF6 gas tank will open and the gas will enter in the arcing chamber. Now, SF6 gas will flow through the arc and it will quench the arc in very short time. After the extinction of arc and interruption of current, the gas moves out from the gas outlets and it will get reconditioned for further use. So friends, these are the different types of the circuit breakers. Circuit breaker is not just a switch but an intelligent protection device that ensures the safety and reliability of electrical system. In short, circuit breakers protect our equipment, wiring, and most importantly, human life from electrical faults. Understanding circuit breakers is essential for designing safe and efficient power systems, making them a key component in electrical engineering. If you want to learn each type of circuit breaker in detail, I have made a separate playlist of switchgear and protection, where you can find videos of all high voltage circuit breakers. Now, if you found this video helpful, don't forget to like, share and subscribe to the channel. And also press the bell icon to get the notification of upcoming videos. Till time, keep learning, keep growing. Thank you.